This video is going to go over question number 3 from the Chapter 3 practice test. We just have several different equations involving logarithmic or exponential expressions, and so we're just going to look at the different methods for solving them. In number 1, we see that we have only one logarithm on one side of the equation, and so I've got to get my variable out of that logarithm, and the easiest way to do that is to convert this to exponential form. So if I do that, it's going to become, here for part A, why is my pen not working? 4 squared equals x minus 3. And then we square the 4, add the 3, and we get x equals 19. Part B is a little bit trickier. We have two exponential expressions, one on each side. And so one option is to try to use logarithms to get the variable out of the exponent. But in this case, because I recognize that 1 over 81 and 27 are both powers of 3, I can actually rewrite this as powers of 3. 1 over 81 is really 3 to the negative 4th. And then that's still to the x. And 27 stylus difficulties here. I didn't even want to write 27. 27 is really 3 cubed. And then that's still to the 2x minus 1. And then my properties of exponents say multiply the exponents if you have a power raised to a power. So this becomes 3 to the negative 4x. And then this one becomes 3 to the 6x minus 3. And now because both sides are 3 raised to some power, in order for that to be equal, the powers must be equal. So we just set them equal to each other. Negative 4x equals 6x minus 3. Combine the x's, divide, do the algebra there, and we're going to get 0.3 equals x. So that's A and B. I'm going to go ahead and just get rid of all that. Pause the video, rewind, watch it again if you need to before I get rid of it. There it goes. All right, part C. Here we see we have both sides have logarithms, but not only that, this one has two separate logarithms. If like this one was gone and it was just log of x minus 3 equals log of 2, well then just like what we did in the previous problem, we would be able to just get rid of the logs and say, well, what is inside the logarithms must be equal. But we do have the two separate logarithms, so first I have to combine into one log, and then I can get rid of the logarithms. And because I have two separate logs being added with the same base, I can turn that into multiplication. So this is going to be log of x squared minus 3x equals log of 2. Now, because these two logarithms are the same, what's inside the logarithms must be the same. And so I just solve that. X squared minus 3x equals 2. I have a quadratic here, so I can try to factor, I can try to complete the square, I can do the quadratic formula. If I move the 2 over, it doesn't actually factor. So my only option here would be either completing the square or doing the quadratic formula. I'm going to skip all the details here. That's not what we're working on. If I do the quadratic formula, I'm going to get down to 3 plus or minus the square root of 17 over 2. And when I do that, the square root of 17 is going to be a little bit more than 4. 3 minus 4 point something is going to be negative. So I know that the negative version is not allowed because a negative is not allowed inside this logarithm. So I'm only going to have to deal with the positive version, which ends up being 3.562. The directions asked you to round it to 3 decimal places, so that's what I'll do here. And you might not have seen that thought about that being negative first, but when you actually work it out, that would be negative, and again, you can't have a negative inside this logarithm, so it's only the positive one that is in fact allowed. Okay. Once again, pause, rewind, rewatch, but it's going away. Part D. Now, it looks very similar to part A, where I've got these two separate exponentials, but there's not an obvious way for me to rewrite 4 and 6 as powers of the same base. Like this I could rewrite as 3 to the negative 4th. This I could rewrite as 3 cubed. There's not an obvious way for me to do that with 4 and 6. So I need logarithms to do this. There's two approaches. I'm going to do the one that I think most students prefer, where I just take the logarithm of both sides. So I just say, okay, log base 10, or natural log of 4 to the x plus 1 equals log base 10 of 6 to the 5x. Now my properties of logarithms say if we have an exponent inside the logarithm, I can bring that outside as a coefficient. So I'll do that. So this is x plus 1 log of 4. 5x log of 6. Now, log of 4 and log of 6, those are numbers. So if you wanted to at this point just use your calculator to figure out what they are, you can do that. I prefer to keep it as an exact answer until I go a few more steps, so that's what I'm going to show. I need to distribute this log of 4. So I'm going to get log of 4 x plus log of 4 equals, and I'm going to just rewrite this so that sort of I can see that this is a coefficient. It's really 5 log of 6 x. Because again, this is a number. It's just a funky looking number, but it is a number. So now I just combine all my x's and then divide. So next step, leave the log of 4 over here. Leave that 5 log of 6, and I've subtracted over the log of 4x. Now, if I had converted these two into decimals, I'd just be able to subtract those numbers, but I'm keeping it exact. So I'm going to then factor out the x. And now it's just x times something. So to get that x by itself, I just need to divide. So I can do that. So this is going to be log 4 over 5 log of 6 minus log of 4 equals x. And if you do actually plug that into your calculator, you should get approximately 0.183. Now, again, I said that you could turn this into a number right here, and that's fine, you can. But don't round too much. If you round these guys to like only 2 decimal places, there's no way you're going to get your final answer accurate to 3. So I would encourage you either to just write down a whole pile of decimals, or save the answer in your calculator, or just keep it exact until the very end. One of those things to make sure that your answer is more exact. All right, once again, I'm going to get rid of all this and do the last problem. What? Let's undo that. There we go. That's what we wanted. All right, my last problem here. Now I only have one exponential, and so I can easily rewrite this as a logarithm and get my variable out of the exponent. Now when I say easily, I just mean more easily than what we did in the last one. Logs are still tricky. Right. As a logarithm, this would be log base 3 of 10 equals 2x. And then just one more step to get rid of the 2. Log base 3 of 10 over 2 equals x. And if you plug that into your calculator, you're going to get 1.048. Okay. hopefully not too bad on that last one at least.